Hi, Algebra 2. So today I'm going to review your linear graphing systems of linear inequalities homework. So we're going to practice graphing a system of inequalities by hand, and then I'm also going to show you a couple examples on Desmos. So the first thing we want to review is how to graph a line, which we went over last class. So we are always going to plot our y-intercept first. In this case, our y-intercept is -2. Plot that right on my coordinate plane. And now I want to look at my rise over run for my slope. So the slope is going to be the coefficient of x. In this case, there's just a negative number there. You remember, anytime there's no number in front of x, it's actually just 1. So there's -1 coefficient on x. And that's my rise. To describe that as rise over run, I'm going to put that over 1. So from this y-intercept of 2, I'm going to go not up, but down 1 because it's -1 and over 1. And I can do that over and over again to build my line here. And I can actually go up the other way. Now, what type of line is this? It's a less than or equal to sign, so that's going to be a solid line. All of the points on this line are solutions to this inequality. So the last thing I need to do is decide which side to shade. So this says y is less than or equal to -x minus 2. So typically when our line is a less steep slope, we can kind of tell which side is below, right, this line. But let's use our point 0, 0 and test this out. So I'm going to substitute in 0, 0. So I get 0 is less than or equal to -0. What's that? -2. That actually just goes away. So 0 is less than or equal to -2. That is not true. So therefore, the side with 0, 0 or the origin on it is not in the solution. So I'm actually going to shade the other side. Okay, so let's do our next inequality. My y-intercept is +2, sorry. And my slope is -5, remember? I can put that over 1, it's still -5. So my slope, or my rise, in this case, my fall will be -5, 1, 2, 3, 4, 5, and over 1. Before I connect these, I only need 2 points to make a line. This is going to be a solid line because it's a greater than or equal to sign. There's my line. And let's test out which side to shade. 0 is greater than or equal to -5 times 0 plus 2. Remember, you can use any point. You can test out any point. I choose the origin because it's usually the nicest to work with. So 0 is greater than or equal to 2. That is not true either. So I'm going to shade the side without the origin on it, which is this side. So once I shade this side, you can see where my solution exists in this little region down here. That's my solution set. And remember, this is just a small window of this coordinate plane. So if you zoom down on this, this would become a very large area, a very large space. So any point inside this space is a solution. Any point on either of these lines, since they're solid lines, is a solution. That means that that point would satisfy both of these inequalities. All right, so if you notice in number 2, these are the exact same inequality lines. However, now we have lost the equal to part. So, and actually they're flipped over. So I'm going to go ahead and plot this blue line again. So -2, down 1 over 1. And in this case, you should be saying in your head, there's no equal to sign. This is just greater than. That means this needs to be a dotted or dashed line. And the reason we make that a dotted or dashed line is to indicate that none of the solutions, or none of the points on the line are solutions. So, almost forgot to shade. So we have to shade as well. So here it was y is less than or equal to this. Now we have y is greater than, so we're actually going to shape the opposite side that we did in the last problem. So that means the origin is in the solution set this time. All right, and then for my orange line, my y-intercept is positive 2. And I am going down 5 and over 1. 2, 3, 4, 5 over 1. And this also is going to be a dotted line. Once again, because that is just a less than sign. And also it is flipped from the other problem. So instead of shading this right side, I'm going to shade the left side. And if you notice, our overlap area is this triangle right up here. This is our solution set right up in this triangle here. And remember, any point inside this solution set will satisfy the system. Any point on these dotted lines will not. So remember, the difference between the solid and dotted lines is that the points on those lines either satisfy if it's a solid line or don't satisfy the solution, the system if it's a dotted line. So these next two I'm actually going to use Desmos for. I'm going to share my screen. So you have Desmos, you might as well use it. I'm going to type the first one right in. So y is less than or equal to 1/2 x plus 2. And y is less than -2x minus 3. So that was nice and quick. Here is my dotted line for my red inequality. Here is a solid line for my black inequality. And my solution set is all in here. Remember that any of the values, any of the coordinates on this solid line up against this region are solutions. Any of the coordinate points on this dotted line are not. All right, and then let's see our last one. So x is less than or equal to 3. That's a -3. That's a vertical line. And y is less than 5/3 x plus 2. So here's our solution set down here. Question for you, will that solution set ever be in any quadrant except for the third? So remember, first quadrant is positive, positive. Second quadrant, negative, positive. Third quadrant, negative, negative. And fourth quadrant, positive, negative. So looks like those solutions are completely bounded, or completely bound to the third quadrant. And a good SAT question there, you know, if they gave you this system and you knew that it was completely bound to the third quadrant, and they asked you here, or they gave you a few coordinate points and said, you know, which of these are solutions, which of these are not, you would know that in order for it to be a solution, it would have to be a negative coordinate point because the solutions are only in the third quadrant. All right, and then I will do number 5, I'll do on here as well, and then number 6, I will graph by hand just to do that one more time. So y is less than or equal to -5 halves x minus 2, and y is less than -1/2 x plus 2. We got a nice big solution set right over here. So you can see that the double shaded region is this guy over here. All right. So number 6, I will finish this one by hand. So I'm going to plot my y-intercept of 3, and my rise is 2, my run is 3. This is a solid line because it's greater than or equal to, and we are greater than or equal to, like I just said, so we're going to be above this line. Okay, and the second inequality, my y-intercept is -3. My slope is -4/3. So I could go down 4/3, but I'm going to run out of room. So instead, I'm going to go up 1, 2, 3, 4, and to the left 3. Okay. How do you know if you went the right way? Well, look, when I connect these, is that going to look like a negative slope? Is it going to fall from left to right? It certainly is. This is going to be a dotted line. There's no equal to. And lastly, if we're greater than, we're going to be on the upper half of it. On this side. So you can see your solution set right here in this region. All right, and then I had 2 more questions for you. Multiple choice questions are always very good practice for PSAT, SAT. Let's use some process of elimination here. So I just want to know which is the graph of this inequality. Well, if you notice, this line is going to be dotted, which is only graphs A and B have dotted lines. So I can right off the bat, you know, heighten my chances of getting this right from 25% now to 50%, right? Now I have 2 choices to choose from. And so this is just the difference of shaded region. So let's substitute our origin. Substitute 0, 0. So I have 0 is greater than -2/3 times 0 plus 5. So that goes away. Anything times 0 is 0. So is 0 greater than 5? That is not true. So the side with 0, 0 should not be the shaded side. A is our answer. All right, and last problem, same thing again. Let's use some process of elimination. Well, we have all solid line inequalities here, so we can't use that. However, if you notice, look at my y-intercept. That's -3. Only these are the 2 options with -3. Y-intercept says that y-intercept of 2. So once again, C and D goes away. And now this is a case of which side to shade again. So let's see. 0, 0 is in the solution, or is a solution. In this case, this is in the shaded region. So I'm going to substitute 0, 0 on this. And if it works, then my answer is A. If it doesn't work, my answer is B. So 0 is less than or equal to 2 times 0 minus 3. 0 is less than or equal to -3. So that is not true. I needed it to be true, which tells me my answer is B.